Hi, my name is Roelof Smit. Together with Saskia Lassesi and other colleagues from the Leiden University Medical Center, I wrote an article on survival bias in Mendelian Randomization Studies, which will be appearing in the November issue of Epidemiology. So, in the last decade, we've seen a huge increase in the number of MR studies, particularly those performed in the two-sample setting. This is where we estimate the instrument exposure and instrument outcome associations in two different samples, two different studies. However, it has been suggested that survival bias might lead to problems, might distort the results of MR studies which include data of older individuals, as these individuals must have survived until study inclusion and are therefore unlikely to represent a random subset of the entire population. We therefore set out to examine the impact of survival bias in MR studies with a continuous outcome for both the one and two sample setting. Our main simulations followed the causal structure I've shown here on the board, where we have the probability of surviving until study inclusion S, which is reduced by our exposure of interest X, but also by a second uncorrelated exposure R, which additionally has an effect on our outcome of interest Y. We consider different age boundaries of study inclusion and different true causal effects of X on Y, and then examined how the instrument variable estimator based on instrument G behaved when there were less and less individuals to draw the data from, less surviving participants whose data could be included in the study. We observed that selecting on survival decreased the instrument strength and introduced downward bias of the IV estimator. This bias was greater for higher ages at study inclusion, and particularly when the true causal effect of X on Y was not equal to null. Moreover, the survival bias was much more apparent in the two-sample setting, where the IV estimator actually combined a biased instrument outcome association with a less or unbiased instrument exposure association. Our results highlight the importance of considering sources and mechanisms of selection, including age-related selection, when performing an MR study. Moreover, they show how the increasingly common use of publicly available datasets, for example from biobanks, may lead to biased analysis in two-sample MR settings, where you just have more room for possibly discrepant selection mechanisms. So our simulations made a number of assumptions, which would be interesting to look at in the future in more detailed simulations. These include that we only proposed one genetic instrument, that we assumed that survival bias would affect different components of the causal structure to the same degree, and that we assumed homogeneous treatment effects. I hope this video abstract has piqued your interest into reading our article, and if you have any questions, please get in touch.